Hello everyone and welcome into yet another live stream, and today we will be doing physics that's too advanced for me. Yes, hi. Welcome everyone. Welcome, let me play some music. So that's what we need. I really have to set up, think of a way to just play everything at the same time instead of just adding all the music each stream. There we go, and then this one and this one exclude, and then this one then play. Make it to a make it stream. Oh yeah, I can finally make it to a make it stream again, Funky Corgi. And I'll be honest, it's a bit of a later stream because I got a bit carried away. I was editing a video and just having fun, and the video editing process I was doing so well that I just got carried away and I just kept doing stuff. So yeah. But today on this stream we won't be editing a video, we will mostly be researching a video actually. Funny enough. And that's because Quarks, my goodness, it's painful. When I finish off, so happens that okay, yeah, eightfold symmetry again. Eightfold symmetry. This time we'd like a different resource. Hi Detefta! What's the video about? This is probably the most advanced physics video I've ever made. It's about particle physics basically. Long story short. The problem is I'm going into the eightfold way of organizing quarks. At this point, it's difficult to find a source that would be good enough. Actually, wait, on Wikipedia further reading, right. I'm pretty certain we have checked it, but I don't remember if we checked it for eightfold way, actually. Hi, Detefta! How you doing? I'm so happy to hear, but I'm so sorry for not responding. I've just been extremely busy recently. But I'm really happy to hear that you're going to open source. That's amazing. Will you have it? Still, because I don't remember. Oh, and that's great. I really wish I could go. One day I'm gonna go to open source one day. But we're not there yet, unfortunately. I'm lagging behind Tefta. If it's just doing well, they are doing fine, most of them. Unfortunately, they're not doing well enough. I hate that mindset, but I have to be realistic at this point, unfortunately. I do have to be realistic, so unfortunately they're not doing well enough yet. We're close, but I can't live off this. But I have saved up money, so it should be fine. Elementary school stuff. Exactly, elementary stuff. Simple things. How to find it. I'm going to try drop your name. You really don't have to. I'm not there yet. I'm not famous. One day I'm gonna, if I'm gonna get invited to open source, then I'll meet you there and we're gonna do like a whole, I'm just gonna do an hour-long ad read for OpenMasu. Get you in contact with high-volume YouTube people. I really don't want to be using you like that. I mean, I do appreciate, I'm not gonna lie. I mean, I would like to collab with some popular, that would be fun. I won't sit here and pretend as if that wouldn't be fun. Make it so underrated. Am I? I don't know if I'm... I don't know. I'm barely walking in the video. I'm having trouble understanding that. I don't say I'm overrated. Underrated, I mean. Murdering, killing innocent turtles. No, that's a different YouTuber thing. No. We have like different YouTuber meetings for that. For murdering, killing innocent turtles. That's a whole other thing. But yeah. Mickey's gonna have 1 million subs. I'm at some point probably. I'm pretty certain Social Blade, was it? Social Blade that has like predictions. Predictions on Social Blade are quite pessimistic from what I've seen. Oh, piss off. Really? My goodness, they just don't let my VPN through. Disconnecting the stream for a second, but I had to switch to a different country because otherwise they wouldn't let me through. The predictions are extremely pessimistic. Also, I have to type in make it happen because the tag make it is still taken by like a brick company, which a whole other issue. Estrogen there. Exactly. No, I just teleported really quickly. It's to Lithuania. I have my summer home in Lithuania, and I just... Yeah, make it... How tall are you? I am 4 feet tall. Yeah, I'm pretty tall. I'm pretty big as a person, you know? Pretty massive, I would say. Make it gonna have at least 2 subs. You're not wrong. So, future predictions. How long would it take for 1 million, according to this? Oh my goodness, that's actually way sooner. Like, I know, it's still way far in the future. Invalid input, I'll have to check this out. 1645. But keep in mind, this is a pessimistic prediction. These predictions do not account for the fact that the more videos you make, the more exponential the growth is. This is still exponential growth, but it's not exponential enough. No, that's wrong. 1645 divided by 365. 4.5 years! Love LibreTech. LibreTech is amazing. The only problem is LibreTech's... I mean, I love LibreTech. I do. I really do. I mention it all the time. The only problem is... I can't spell, apparently. .org, was it? I think .org. The problem is... It doesn't have the resource I need for a video, and I'm really upset with LibreText. Well, I'm not. I still love LibreText. It's amazing. I love it. Oh my goodness. Okay, we're gonna go through this PDF in a second. Exactly. But I am really excited. I feel really bad, Theft. I really do, for not like replying to your message. I really do feel bad. It's just that I'm sorry. I'm just sorry. You know what? No, I'm gonna do better. I shouldn't apologize. I should just do better. Wrong mindset, make it. Don't apologize. Just do better. I am really happy, and I really hope... Just send me all the pictures when you get there. I want to know everything. I'm really curious. Because this is fun. Because from what I've heard, open source is such an amazing community. I absolutely love the internet communities of... Like, scientific internet communities. I absolutely love them. It's amazing. It's so wholesome. It's always so unbelievably wholesome. And I just get it. I don't know if you all know this, but I kind of like science. It's sort of my thing. I'm unbearable at parties. That's all I talk about. Anyhow, symmetries in physics. Isospin and the Eightfold way. Haha, it's painful. I have a question, if I may. Go for it, Farmain. Go for it. I'm just gonna sip some more coffee. There's mostly milk. It's half a cup of coffee and half a liter of milk. I have a big cup. Open source science is better than private-led paywall science. I do agree. I've already mentioned it a lot of times that the current, you know, private research is an unfortunate consequence. I really don't like the whole private research, the whole, you know, publish or perish culture, let's call it. It's really upsetting. I do believe that since science is generally for the well-being of humanity as a whole, I mean, you know, if someone discovers something or if someone proves something, that's information, and information that's free to distribute. Which means if someone discovers something, that sort of makes lives better for all of humanity. So I do believe that we should allow people who are willing to put in the hours, we should allow them to pursue that kind of research without them worrying about, you know, having to publish 7 papers a day or starving to death. That's a whole other thing. How large do you have to be to get for on open source? I think it was something around 1 million. I mean, Nilered is there now, Nilered, but also there are some less popular creators. I think next year could be. It could be it next year. Call me an optimistic son of a gun if you want, but next year I could try. I have a year to make videos. Just go virtually, like make it Roboto tent. I'm so upset that I can't do robotics. Like, I constantly want to get into robotics, but I constantly get distracted with just not having money. I can't do robotics. I really can't. I'm decent with electricity. I suck at mechanical engineering. Absolutely suck at it. I really want to learn robotics though. This is fun. You've built an infinite amount. You built infinitely time more robots than me, because I don't count the ones I made robots. All of them didn't work. I think you're 5'6", 5'8" tall from a figure in your videos. How could you possibly guess that? There is nothing in my videos that you could use as a reference point. I could be... No, I feel like we should go with 4 foot. Let's normalize not being tall. Silence topic interests me, that's why I have no friends. That's actually no, I wouldn't say it's an excuse, Annabelle Berry. You should still go look for friends. I genuinely do mean it. I don't want to give off the wrong vibe here. I don't want to encourage people to be antisocial, because I'm not antisocial. I really often play it off as a bit, but it's important to be social. Just being social feels nice. And I don't mean like partying all the time. That's not what I mean by being social. Just finding a community of people or a circle of friends that you like. If you like just talking about... Or if you're silent as the topic interests you, just find friends who are interested in the same things. That's what I do. Relativity says that nothing goes faster than light because it goes backwards in time, creating paradox. We're looking at space-time diagrams where y equals time, x equals space. 45 degrees curves are showing photons. But I can draw curves on speed that are faster than light, but still go forwards in time. How does it conflict with the rest of theory of relativity? I'm curious. The pickle... Oh my goodness, family. That's an incredibly advanced question, I'll be honest. The reason that I know for why... I actually thought the reason was different why things couldn't travel faster than light. I mean, they do break causality, I don't know in what way, but I'm pretty certain the reason was relativistic energy. That's at least the reason I found. So, energy-momentum relation, you have the... I always have trouble finding the equation. But basically, with the Lorentz factor. There we go, that's the one. A Lorentz factor into energy equation gives us this. So basically here we have equation for the energy, and you can see that... Wait, am I an idiot? There was a way to simplify this, which made things significantly easier. The point is you need an infinite amount of energy to accelerate something, accelerate a massive object to the speed of light. Which means if you want to accelerate something further than the speed of light, you need more energy than the infinite amount. That's why you can't accelerate something faster than the speed of light. However, things going faster than the speed of light do break causality. Hold on, I'm trying to remember the relativity knowledge. Oh my goodness, which one was it? Time dilation, wasn't it? But you couldn't draw curves on a speed diagram that fast and light but still go forwards in time. I see the problem there. Have you accounted for the curvature of space-time though? Because it's a photon is going at 45 degrees in relative to an observer, correct? From its own point of view, a photon is going at 0 degrees, going straight through. You stumped me, I'll be honest for a minute. I'm not a physicist, that's a good question. Because, yeah, like, obviously, the reason why faster than speed of light would go back in time is time dilation. However, if you draw a diagram like this, then the diagram certainly does seem to be correct, and it's very much not going back. Make it. I am 5'7" and I am 70 years old by now. Do you think that I am going to make it to 5'9" until I become 20 years old? Why the crying emoji? Normalize being short. I'm short. I'm 4 feet or something. I don't measure. I don't have all my rulers and the measuring thingamajigs, you know, the ones that people used to measure are too short for me, so. Hey, at least I know I'm not 11 inches. That's good. Actually, I completely guessed. What's my biggest measuring thing? How large is it? There it is. Oh, it doesn't even have inches. I am so European. Being short is beautiful and still grow until 2024. 27. Yeah, exactly. Now we should be being short. There's nothing wrong with being short. Take it from me, I am short. A while back, when we did the Sons of the Forest child checkup, or maybe it was the Forest child checkup, I don't remember. Tefta made a thumbnail for that video. for that live stream, and in the thumbnail, Tefta basically said me and himself to be the same height, and that was such a compliment for me at the time, because I know for a fact I am shorter than Tefta. Go sleep now, you'll grow faster. Or just, you know, being healthy, that's also why I encourage sleep. Speaking of, let's drink some coffee. Yeah, I still remember that thumbnail, because I was so surprised they actually put us the same height, because I know for a fact I'm shorter. Yeah, okay. Right. Textbook. Speaking of advanced physics... This is fun. I really should go more into like engineering kind of sciences, because I know quite a lot about physics at this point, but not about physics that you can actually use on human scales. I know a lot about particle and quantum mechanics. Natural extension of Eightfold way. Okay. Set of symmetries have played similar role in the development of particle with nuclear physics. Half-Life of Quarks is the next book, and whoa, what's it about? Half-Life of Quarks is about development of I'm guessing completely. Had a high explosion when I was sleeping, and somehow my sleep cycle 8 hours I grew faster. I have nothing to add there. Farmer main. I'm so sorry, I keep mispronouncing it. Farmer main just gives solid advice. That's, yeah. Symmetry of quantum mechanics and the transcendent energy levels. The fact that facts have half-lives and get proven wrong after a given time. I mean, makes sense, I suppose. That's why it's so important in science to realize that there is nothing that we know for sure, and we don't even know for sure that we know that there's nothing we know for sure, which means we don't actually know if there's nothing that we can know for sure. Maybe there is something we could know with absolute certainty. Isn't that fun? Isn't that a fun little paradox to keep an open mind? Isospin, okay, the symmetry and the different states of the same particle. Oh, okay. Which is Quark model as a natural framework to represent the observed symmetry. We will apply this concept to analysis of nucleon and nucleon mass and scattering. In the final section, we will discuss SU3 symmetry, the one we actually want to get to, of 3 quark flavors. The algebraic structure and the representation of SU3 will be discussed in parallel to SU2, and particle families will be identified in terms of representation of the underlying symmetry group. Okay, fun. That's why I like so much. Another video I want to make, and I am going to make either this month or next month, is actually about the history of science a bit more. And to be exact, about quarks, but in a different light. As in, how do we know that quarks exist? Because the answer is we don't. And what I really like about the science of tiny things, you know, quantum levels, is that the further you go, the less the word exist, the more like the word exist loses its meaning. So basically, what does it mean for a chair to exist? Well, if you can, you know, if you see it, if it exists, we all have like our own intuitive way of interpreting the word exist. However, once you get to the quantum level and particle level, do things like quarks exist? Well, they don't. Well, they're not real, right? They're not real because they seem to work if we put them into our models, but we can't actually check that they exist. They're way too small for that. How accurate is the theory for quarks? Very, very accurate. It is incredibly accurate. It's accurate enough for, you know, for us to build a large hadron collider, so I would say it's pretty accurate. Like, the thing is, Large Hadron Collider. If our theory about quarks is wrong, then this is worthless. And that's kind of I would argue, the most advanced building. I don't even think it should be called a machinery. It's a building. The most advanced building we've ever built, so. It comes down to what we can measure and how. That's precisely what's so fun about it. when it comes to a quark, you can't measure a quark. You really can't, because what are you supposed to do? You could fire a photon at it. That's some idea. The only problem is photons and quarks have the same scales, or rather, energy is of the same, roughly same magnitudes-ish. Which means a single photon can tell you at most maybe a property of a quark, like its energy. You smart enough? I actually don't know exactly the theory this much. You can measure a quark. Well, you can measure that it exists. Not that it exists. You can measure that it interacted with something. Use an electron by an electron microscope or something. Electron microscopes, that's an electron. That's still same size. Well, actually, it's not really the same size. I just really want you to realize atom model to scale. Of course, this is not gonna be quite as accurate, what I'm about to say, simply because it's quantum mechanics. LIGO. LIGO? What's LIGO? LIGO Quarks. Oh, laser interference gravitational wave observatory. Oh, this is the gravitational waves experiment. Oh, I see now. Okay. Yeah, okay. I don't know. I still feel like a Large Hadron Collider would be more advanced. I mean, LIGO is incredible simply because of how it's the proof of relativity, right? The only problem is that it's so insane when you learn about it. That it's what you basically need is, what was it? It was like a couple miles long laser, if I remember correctly. Actually, I have a Wikipedia page, I can just open. Focal measure length of effective. Yeah, okay. These observatories use mirrors spaced out 4 kilometers, so it's 4 kilometers apart, and then bounces around. So you effectively need 1,100 kilometers of less than 10,000 of the charge diameter of proton. Oh, but that's charge diameter. Femtometer. Oh, that's bigger, I think. Femto, that's single particles, right? The size of an atom. Ascending principle disregard info of the other. What's the size of an atom measured in? Yeah, 10 femtometers. Okay, so this is 10,000 charges of diameter of a proton. So this is one, effectively, because this charge diameter of a proton, that being 1 femtometer, which is about an atom, which means 1/10,000th of an atom. Incredible. Absolutely mind-boggling. How do we even measure this, actually? Advanced LIGO, yeah, because, you know, this is just the basic, right? We obviously need the advanced one. After 2010, LIGO for several years for major upgrades. Advanced LIGO detectors. Oh, that's certainly a science moment when, you know, we had something like LIGO, and we needed an advanced LIGO, because, you know, LIGO by itself wasn't good enough. This is madness. Because this was, what, 2 black holes? Or 2 neutron stars? I don't even remember what they measured. Experience to measure the change. Absolutely incredible. Like, if this isn't filling someone with hope for mankind, noise cancelling is insane. I mean, I would assume, oh my goodness, I didn't even think of that. If your measurement is up to the scale of 1/10,000th of a charge radius of a proton, obviously you can't have any interferences, because otherwise it's gonna ruin everything. That is madness. have to combat all vibrations. I don't even know how you would this. How you dampen them this much. You know, okay. I always thought that Large Hadron Collider, or the even larger one they're building, you know, they're gonna build soon. Whatever it's called, I don't remember what the larger one they're gonna build soon. I always thought that this one was the most advanced, simply because, well, casually measuring quarks. Like, at this point, the thing is, right here, measuring quarks is not something that's a big event, that's something that's happening however many times per second. But I can see the argument for LIGO, I'll be honest. It's maddening how crazy cool LIGO is. To me, it's more maddening the scale of it all. This is basically, we're measuring something over that came from, wait, came from what? It says right here, I already forgot. Was it black holes, neutron stars? I never remember. I was gonna be after light years. Okay. Collaboration published a paper about dictionary of gravitational waves was detected of two solar mass black holes merging. Okay, it was two black holes then. About 1.3 billion light years from Earth. So what we basically needed is two black holes. To be fair, they're not that big for a black hole, but still, two black holes. Saying not that big for a black hole is kind of mad. Two black holes. 1.3 billion light years away. I'm assuming that's why the gravitational waves were so subtle, actually. That actually makes sense. Of course, the further they go, the smaller they get. Yeah, humanity is dumb. Why wouldn't just we travel to these black holes? Then we could measure the gravitational waves using a normal laser. Honestly, quite illogical, I would say. Do you think the future circular collider be any better than Large Hadron Collider? I mean, it certainly will be. Otherwise, like, the thing is, I am not clever enough to actually give any insight. The reason why I think is that the even larger collider will be worth it is because scientists who want it claim it will be worth it. They know their stuff, so I'm assuming. And also, it really often gets underappreciated just how many things we still do not know. How still cutting, bleeding edge current day research is. That's because we mostly only focus on things which are obvious to us by now. Use black hole curve. Laser. Away from black hole, exactly. Would the gravitational wave dislocate my bones? A gravitational wave. Actually, what is a gravitational... How would the gravitational wave work, actually? That's a good question. For light, it's obvious, because light has to... You know, speed of light, the most constant of constants. I mean, the wave, okay, you know what, this is probably obvious, probably just oscillating back and forth. Duh, that's what wave is. Stretch and vibe with it. I don't think gravitational waves would stretch. Actually, I'm not thinking today, give me a second. Damn it, I'm struggling even with basic relativity, what's wrong with me? I started the live stream to research on particle physics and I'm struggling with basic relativity. I know the math. I mean, the math would seem to be that if it's truly just a wave, then it will be just gravity. A wave of gravity, literally. Obviously, that's what it would be. And then gravity has the same effect as acceleration in relativity. Pretty much the same. So I'm pretty certain, if I don't remember correctly, it's length of contraction, time dilation. Yeah, isn't light too big to be able to affect subatomic particles, though? No, that's because... Well, problem there is that you said, isn't light too big? You can't think of it this way. Wave-particle duality, basically. Light, when you think of light, you shouldn't think of a ball. Light, a photon, a single photon is not really a ball. Mickey, can you draw a quark for us, please? I can't, actually, no. I actually can't, hold on, that's a for another video. That's the thing I was rendering. Thinking with functions, indeed. The thing is, when it comes to photons, the way I always like to draw photons is this way. Ah, beautiful representation. Wave, particle, duality. Mwah, chef's kiss. The problem is you can't think of light as a ball, so asking how big light is kind of loses meaning. I'm pretty certain when it comes to scale, what we mostly care about is the wavelength, which means if you want really small light, in quotes, you just need to make the wavelength shorter, or give it more energy. Photons are point particles, they don't have a size. But they are a wave, you could, well, we mostly use the wavelength for the size. But yes, in quantum mechanics we do assume things to be a point, because why not? It's quantum, it's elementary stuff. I'm trying basic relativity makes as well the vast majority of result is struggling to do trigonometry. Basic relativity is not difficult, it's basic, as the name would suggest. Most of these things aren't as difficult as they seem. So a ship would shake and I would hit once my ship if it's just acceleration. It's not... No, it has the same relativistic effects as acceleration. Allow me to show you what I mean. Once again, my taskbar broke. Damn it, Windows. Cooperate with me. What's the matter with basic relativity? And then, yeah, I'm gonna stuck with this laugh. So... Acceleration, come on, make it together. Lorentz factor. It's one that could help, actually, as an anchor. So Lorentz factor, we have it right here. That's used for, you know, time dilation, length contraction. Whenever you want to learn about these, you just take the Lorentz factor, and that gives you the appropriate value for acceleration. However, when it comes to gravity in relativity, it has a very similar effect. General relativity, what am I looking for? I'm looking for gravity's effects on... Yeah, there's gonna be a lot of words gravity in here. I'm mostly looking for equations. Are there gonna be any equations? This is how you know it's advanced mathematics. If there are no symbols, that's how you know it's not gonna be a fun read. Yep. Gravitational time dilation and frequency shift. There we go. Experimental principle holds. Gravity influences the passage of time. Light sent down the gravity well is blue shifted, whereas light sent the opposite direction is red shifted. Collectively, these two things are non-gravitational. Frequency shift. Yeah. Do we have an equation or do we not? Gravitational time dilation. May I please have an equation? That would be nice. How can energy exist without the mass to have the energy? Well, it's because magic. Honestly, if you're looking for an answer to an elementary question, you won't find it. There we go! See, you can see what you mean. That's actually... that's such a perfect graphic. Exactly what I meant. This is what I meant when I said that acceleration has the same consequence as acceleration. Acceleration has the same consequence as gravity. Basically, time dilation is something that happens when you accelerate and when there's gravity. And as you can see, basically, the higher the velocity, the more dilated, the higher the gravity, the more dilated. Which means that, from that point of view, a massive gravity... I don't know if it works the same way for length. I think it does. But basically, what that means is that with a massive gravity, you would experience same kind of time dilation as with acceleration. It's actually how Einstein came up with relativity. Just imagining a guy falling off a roof and then was like, hey, him falling off a roof is kind of the same as Earth coming towards him. And then, boom. After a lot of weed was smoked, relativity. Is tau something rotation? No, it's time. Tau is for t. Tau is because it's fancy t. And also, how can energy exist without mass to have the energy? Energy, you should think of energy as change. Or rather, not capacity for change, only... Not possibility change, only... How change is gonna happen. If you have something with a lot of energy, that means it's going to change a lot of things. That's how you should think of energy. So if a photon has energy, it doesn't actually mean that it has mass. Well, it actually means that the photon can change something. And also, the way more confusing part, in my opinion, is the momentum. How can something without mass have momentum? That's a whole other thing. Because I'm pretty certain energy of light is what? I think it was PC. I think that was energy of light. Let me see. Radiant energy, right. Or rather, energy of a photon. Oh no, wait, it was... Yeah, no, PC, but it was depending on the wavelength, wasn't it? H bar... Oh, H bar what? H bar divided by... lambda? I think. My goodness, I'm not thinking well today. Gravity can be simulated in future shapes just by constantly accelerating 1G, decelerating halfway. I think 3 weeks. I mean, I don't think accelerating and deaccelerating would be the best way to go about this, because, you know, if you accelerate, deaccelerate, it's gonna go the other way. Spinning is an idea, certainly. Because when you're spinning, then you basically constantly have to accelerate. Rather, you constantly... spin is confusing. I don't want to actually get in spin. I take it back. Don't listen to me. Drink some coffee. I agree, I should. This is one of the best, my favorite things I bought. I have extreme buyer's remorse, but a while back, a couple months back, when I was in shops, I just saw like a massive cup, like a liter cup, was just there, and I haven't regretted that purchase ever since. It was worth it. I would have paid triple the amount of money for it. I should buy more of these cups, actually. 10 around halfway. Accelerate, deaccelerating. I suppose. Okay, it's time for particle physics. The density of energy in quantum mechanics is related with symmetry. The last symmetry of the quantum mechanics system. The external symmetry operation of quantum mechanics system is given by corresponding Lie group, our beloved. Then, okay, so we have Lie group, we're exponential sum. Boy, I even Reblax didn't want to delve into Lie groups with me, so I'm scared. Can we do Lie algebra? I've heard that it's an alternative. Decelerations are accelerating the opposite direction of your velocity. What's fun about it is that it's deceleration is just acceleration. That's because, you know, it's relativity. So, you depending on the frame of reference, you don't actually have velocity. So deceleration is just acceleration. You don't even have to go in the opposite direction. Or rather, deceleration doesn't exist. It's a myth made up by the big decelerate. By big breaks. The action of symmetry generated energy against state leaves that energy of the same invariant. If newly obtained state is linearly independent of the original one, this applies to the in the spectrum. If linearly independent of the original one. Can be defined by angular momentum operators JK studied in chapter 7. Oh, I don't want to go through all the chapters. Can't I get a full book, by the way? This would be a painful read, actually. Oh, how lovely. Big breaks again. Exactly, big breaks strike again. They want us all to slow down. Lie groups split central on the discussion of map degeneracies. Of course they do. Of course they do. 50 times design. That's what you get from most universities. Last modified 1999. Okay? Last modified 1999. Oh boy. That's fun. I don't think Tuesday and Thursday 1 to 2 p.m. I don't think it's gonna be there. We don't explain quantum mechanics, but we get you used to it. Oh my goodness, I love it. I don't even know. Hold on. Quantum mechanics PDF. Oh, I can just get all the chapters. Oh, I'm such an idiot. Yeah, I can. I can just copy the link. Oh, there we go. So we could go through all of them. Oh, this is the last chapter. Oh, that's no. That's not good. Is it? Oh no, oh no, oh no. No, not the fun. I think that's all that you make it. Oh, that's mean. Oh wait, hold on, that's what, 26 years at this point. Whoa, time's fly by. 1999 was that's okay. Okay, I'm bad at tracking passage of time. That hit me for a second. I thought you were calling me like 14 or something. For a second, I genuinely thought you were calling me 14. Alrighty then. So we have a whole, like, lecture notes thing. Yes. So this because the particular example. Okay. You're 24. I think I was born 2000. Right? Yeah, it's 2024. Angular amount of operators again, angular presence in order to illustrate the first particular example of searching emotions. Okay. Dynamics particle moving 3 dimensions under the influence of spherically symmetric potential have discussed spherically symmetry by the combination of Hamiltonian angular momentum operators. Wait, this actually might make sense. No, you wouldn't believe it, it might make sense. Influence spherically symmetric potential. People born 2006, 10, 18 this year? No way. Oh yeah, this is 2024, isn't it? I keep forgetting. Make it an absolute fossil. It's mean. Both are full of silica minerals. I'm mostly just abyssalite. System can be reduced to one-dimensional radial equation, which yields a set of eigenstates of the form this. Each energy level is 2L plus 1 for degenerate. Oh boy. That's an equation. That's actually a surprisingly lovely equation, but that's fold, unfortunately. This generally follows the fact that any addition is represented by the element of SO3. Oh, this is SO3. Okay, then never mind, understand. A generated state is the same as the original. Presence of additional symmetries may further increase the degeneracy of the system. As an example of this, we will consider the Coulomb problem of Hamiltonian. From elementary quantum mechanics, we know the spectrum of a hydrogen atom. The energy levels are, and there we go, where the orbital angular momentum air. Why am I yawning? This is captivating. It's a captivating read. Values 0 to n-1. The energy levels are totally independent. Well, for example, states 3, 3p, 3d have all the same energy. We want to understand this extra degeneracy in terms of the extra symmetry of the discharge and given by the additional set of symmetry there's interest below. Classically, the additional symmetry generators of the Coulomb problem are the three-component so-called eccentricity vector discovered by Hamilton. Okay. More coffee? We'd love some. No, I just needed a second. Lewis Hamilton. Hamiltonian, that's a reference to that hit show. Finding father without the father, get a lot farther by walking a lot harder. That's a dead reference at this point. Mika, do you think there's a limit on how many possible elements there are? Which ones? You mean... What do you mean, what do you consider an element? You mean atoms, as in periodic table? Or do you mean elementary particles? Or do you mean chemical elements? Oh, I see. So atoms. No, I don't think there is a limit, to be completely honest. I mean, there's a theoretical limit. Because you need more energy. Well, there's a practical limit. I don't think there's a theoretical limit. Actually, what makes big atoms unstable? Is it the residual strong force just vanishing away? Or is it the electrons? Oh, it might genuinely be residual strong force not being strong enough. Repulsive strong force being strong, so electromagnetic. Yeah, so oh wait, that's actually... No, that makes sense. Did I guess that right? Really? Boy, that feels good. Yeah, so basically too many protons just pushing each other away, residual strong force not being able to make up the difference. I'm actually pretty certain that's why you need more neutrons in atoms, simply because you need to boost the residual strong force against the electromagnetic, trying to push it away. This is difficult stuff. I'm not having fun. I'm looking for one piece of information. I'm not gonna understand this. This is too advanced for me. Yes. Namely, the proton and neutron behave identically under so-called strong interactions, and that their difference is solely in their charge content. Okay, if the proton and neutron are to be viewed as two linearly independent states of the same particle, it is natural to represent them in terms of two-component vector analogs, the spin up and spin down and spin half system. Alright. If we added negative hadrons, it would stabilize the nucleus. I don't know. Simply, I think it wouldn't be that simple, simply because you need to make a hadron somehow. How would you make a negatively charged hadron? Hold on. Which one had the... Up was positive, correct? I'm pretty certain you would need 3 down quarks to make a charge 1 negative. I haven't gotten into strong interaction yet, so I don't know how it works. Shove 2 electrons into a proton. Yeah, that ought to do it. Is a quark a lepton with color charge? Actually, yeah. Yeah, I mean, you're not wrong there. Kind of the whole definition of leptons, if I remember correctly, is that they just don't have color charge. They don't interact with the strong force. Or rather, they just don't like interacting with stuff in general. The rotating in the quotes is really killing me. Into each other. Like, all this recognizement space enables us to realize what we already know about SU2 symmetry group first. For example, we'll be able to use the familiar Klebs-Gordon coefficients to combine estimates of 2 particles the same way we added spin in chapter 6. I really feel like there is a lot of context which I'm missing out on. Dark symmetry, strong attraction. current charge. Mass difference is... Oh my, this is so advanced. Decaying neutrons, spelling disaster the stability of matter. Isospin symmetry is not an exact symmetry of strong interactions, albeit the approximate one. Therefore, it remains a useful concept, fed in that, as we shall see below, it can be seen as part of larger, more approximate symmetry, which is of great utility to classify observed particle families. As good quantum numbers. I have to stop using although they attempt because it gets confusing the whole when the words that we used to mean something we are familiar with becomes unfamiliar. This is not just physicists, it's everything spin. That's also chemists and mathematicians. Scientists in general have to just stop going with stuff. Like, call it charge fine, good for you, but come on, spin. I had to clip your Einstein inventing relativity comment. I already mentioned it on multiple occasions that in my opinion, this is my genuine opinion, that the Nobel Prize that Einstein got should have been split in two. One half should have gone to Einstein, the second half should have gone to his dealer. Because the amount of weed you must have smoked in order to come up with something like relativity. Thoughts on proton decay, real or fake? Proton decay is fake because it hurts my feelings. Proton, you mean what? Proton decaying into a neutron? I don't quite understand why it would be fake. Accept negligence gives a rebirth and decay. No, I'm all the way on Zinch. Sorry, my guy. I'm all for change. I'm all for change and sacred knowledge. Has spent all their creativity actually discovering new stuff and left none to name the discoveries and do the equations and stuff. I mean, there are certain things, for example, brackets. Brackets are everyone's favorite example of, you know, something that actually works, something that's actually good notation. As you can see, brackets. Proton decays into a lighter subatomic particle. It's hypothetical. Oh, then I haven't heard of it actually. How would that work? You would need it. Isn't up and down quark? Aren't up and down quarks the lightest? Wouldn't you then need to switch up one of the quarks for like, or remove one of the quarks? I don't quite understand how this would work. Into a pion. I mean, would have to, right? Is neutrino a charged lepton without the electromagnetic interaction and a quark a charged lepton with color interaction? Why are you using leptons as a reference, Randy? I don't understand. Why leptons? You can just say elementary particle. Quarks are elementary particles that interact with a strong force. Leptons are the ones that don't like to interact with stuff. Boron? Wait. What was the name of it? Boson. Bosons are the ones that carry forces. And then Higgs boson, which for some reason is an outlier, even though it's... That's only because scientists refuse to accept that mass is an interaction. Just live in denial. Bosons leptons without fraction spin in different charges. Basically, time dilation is something that happens when you accelerate and when there's gravity. But it's actually how Einstein came up with relativity. Just imagining a guy falling off a roof and then was like, hey, that's a true story. The roof is kind of the same as Earth coming towards him, and then boom. After a lot of weed was smoked. Oh, I understand, yeah. I mean, this is a true story. Well, we can't be certain about the weed, alright? We do have conflicting sources about the weed. Although, like, duh, come on. There's no way he was just sober. That's no real. It goes weird for anyone else. Is my mic going weird? Oh, that's not good. Am I back? What happened to my mic? We're listening to a recording. Yeah, I was listening to what Tefta sent in Discord, the clip of my Einstein weed comment. Maybe he was smoking something. I mean, Einstein definitely was. There is no way you can come up with something like this sober. I refuse to accept it. There is no way. Like, how? Smoking Einstein's weed. It's fucking child radius. Oh boy, this is fun. Eightfold away, I'm not gonna understand anything. Discovery of the concept of strangeness mentioned in the previous section. Let's just say I skipped that. Let's just assume for a second I skipped over the concept of strangeness. It was motivated by existence of particles that are produced strongly but decay only weakly. For instance, K+, which can be produced this way, cool. Has a lifetime which is comparable to heavier. Given independently in postulate the existence of separate quantum number S called strangeness such as this and this and this. Was assumed that strong interactions conserved S, while weak interactions did not. Makes sense. Okay. Relativity to classic Google. No, we don't have the budget for that many hard narcotics. Because the figuration between drugs is I mean, I do like just how comically obvious, you know, the underlying concept of relativity are. Like, hold on, my brain isn't working. One of the things that motivated relativity was that everything is relative, like, duh. Another thing was that things happen after another, like, duh. My work ethic is 1 week of hangover, 1 week of hyperfixation. Hey, if it works, it's important to rest. Hangover, why not? Because of as Liz, what weak structures did not, hence strangeness changing strong decays were forbidden, giving it higher than usual lifetime. Classification of the newly found particles was from higher multiplet structure. This is used in the case of Isospin, however. Strange particles from the nucleus, for example. Okay. In the light of the quark model, it appears an obvious generalization to add another component for extra quark Isospin vector with... Okay, so this! I get it now. That's why right here we had SU2. Wait, is that really why? We just re-generalize like a proton-neutron thing into quarks. Is that pretty neat? I will reinvent physics after watching something fall. That is really how it always starts, isn't it? Newton's apple, Einstein's guy. There's a relation happening with two guys who watch things. It really is. There is really something to it. You just can't think. You just can't create a theory about gravity without watching something fall. That's why quantum gravity failed. That's the reason. People who were in charge of quantum gravity never never saw anything fall. The great realization of someone rising. Next gonna be house. Yeah, it is getting bigger, isn't it? Okay, so we have this. In this case, transformation that rotate the components into each other while preserving the norm have to be elements of group SU3. That's the Lie one. However, history followed the reverse of this part. First particle multiples when defined presentation is a free group. Same when nucleus patterns were discovered as present Isospin. Then came the question of what the fundamental representation correspond to giving rise to the quark model. As quarks were never directly observed, for a period they were considered as useful bookkeeping devices without physical content. Makes sense, I would say. We need to drop quantum particles. Kind of a problem with that, you know? Garfield, don't think of a fabric of reality. No, funny comic. I do like it. Up quark can release an electron and turn to a down quark, and the down quark can release a positron turned into an up quark. You mean the weak interaction of a neutron to proton and proton to neutron? I think there's also a neutrino there. Impossible to solve. You have to be falling. However, in order to have enough time to solve it, you have to fall from a height that would kill you. Exactly. That's the specific reason for why we don't have a theory of everything. Symmetry and quark. The other no quarks, charm bottom and top, beauty and truth. My goodness, that's madness. Asking heavy, okay. Before discussing the significance of physical implication of the quark model, we established some mathematical preliminaries about group SU3. In the effects, it will resemble the more familiar group SU2 as caliber chapter 5, but there are a number of subtle differences. The reader shall know that most of what is being said is trivially generalizes the other unitary groups. Stick to and 3 in the following. The reader, okay. Given a complex vector AK of 3 dimensions, we want to find the transformation that preserve. You're right, we already went over this. I don't want to go over this again because that was painful. 3 dimensions. Hence, the group has 9 dimensions. What way U by phase still leaves no environment, therefore can be decomposed to a direct product. This consider 3 by 3 in the dimension of the intended because the additional group has 8 dimensions. That's actually even more exact than what I've... Hold on, let me ping Reblax again. I know another SU3 update. What's the net charge of the universe? Wouldn't it be 0? It's actually 1 because make it is so attractive. Great realization of a man drowning. I just make it reading something using Blender or playing something. Everyone here just watches him and talks about random stuff. That's the best kind of live stream, isn't though? I like chatting. I prefer chatting than, I don't know, boxing. Express them as SU like this, where 8 linear dependent matrices we shall okay. The indeterminate condition requires that all are traceless and determinant. It's equal to this. These are basic constructed analogy polyalgebra spin operators. So we have 8 of them. Wait, is that the only 8? These discussions hit hard. Yeah, because physics is fun. Day is wrong. Oh, yeah, you are right. I haven't changed it, have I? That's correct. Oh, nice, we fixed it an hour into the live stream. About time. Okay, I have one problem only. What are these? I don't understand. So, the SU3 ones, right, they are basically rotate. That's the word we're looking for because we want to know exactly what it is. There's only one. 12 into each other while preserving the norm after the elements of group S3. Why rotate? Why are we rotating them? Wasn't there another one where it said oh, because I... No, wasn't there another one for the double? Also governed by an SU2 group rotating components. Okay, analogy concepts regarding the rotation of free space as discussed in chapter 5. Okay, we need chapter 5 then. Spin! No! No! Okay, I see how rotating would have something to do with spin, but... stream quality just tanked. Oh, it really did, didn't it? I know why. How to fix it. Everything's good on my side. Every quantum theory could predict antimatter particles with particles negative charge of the theory. So what if we can't quantize gravity because there is no negative mass? I don't think that's the problem. The problem is something called renormalization. Basically, I like to think of it as a limit. So, limit of quantum mechanics. In quantum mechanics, you're dealing with things which are points, but in reality they can't be points. Simply because, you know, nothing can have a size of 0. And because of that, we just assume that they're kind of like taking a limit in mathematics. When you take a limit in mathematics, you're allowed to figure out what different equations mean, even if technically they would be like infinity divided by infinity, infinity divided by 0, whatever. And so in quantum mechanics we have the renormalization, where we basically renormalize stuff. So we take something, bring it to 0, and then bring it back. And we can't do that for gravity. Make it just the Klebs-Gordon coefficients to combine the isospins of 2 particles. God damn it, why didn't I think of it? What are we looking for? SO3. Okay. Rotation deliberate design determinant. Can I just get what it means? Because I'm not gonna lie. You have solutions, but they make no sense, right? Like he's spitting out infinities. I don't know exactly. That's all I know about gravitons. Just that they don't make sense because they can't be renormalized. That's all I know. It's been a second since I read up on unified field theory. Yeah, it's been a second since I figured out how spin works. Okay. Now shall the group properties all the following assume this one, especially okay. What am I looking for exactly? That's a good question. Like exactly what am I looking for? I don't want to go through the entire PDF because it's going to be extremely complex and kind of above my pay grade. Rotating components to each other in abstract isospin space. Isospin. Oh. Huh, that's okay. I see. Alright. Let's say then that space representation. Oh, maybe that actually seems pretty similar. How rotational transformations act in a single particle wave function. We learn that transformation patterns and invariances are connected with the angular momentum states of quantum mechanics. Makes sense. Wait, why are we rotating them though? Because we're not really rotating them in space. We're rotating them in an abstract space of. Why are we rotating them? I don't... Am I crazy? Why are we rotating them? Am I the idiot here? We have an abstract space of up quarks, down quarks, strange quarks, and we're rotating it. I don't know. The point is we have this. Yeah, we shall rely around the group meaning apart from the context. The undetermined condition requires that all traceless indeterminate equal to this. Increased basis is a constructed analogy of the Pauli algebra spin generators of the relation. Fundamental defining group representation of SU3, as in the case of SU2, higher represented by the same structure can be found. The fundamental relation is to be perceived. A set of generators is not the most useful basis of study SU3. In the case of SU2, the identification of ladder operators. F-spin operators. Another change of basis, we arrive at the standard form of generators of Lie algebra. This is tough. This is really tough. I think I'm gonna end the stream short, simply because I've been really productive today working on the video, and I'm gonna keep doing it. The quarks construct Isospin was like protons and neutrons. But why do we rotate? That's the question. It would all make sense if I knew why we... Unless rotating is just the weak interaction. I have to look into the stream. Yeah, I got it sooner because I'm working on the video. The video is gonna be out tomorrow. How about that? Can I persuade you with that argument? If I finish the stream now, the video is gonna be out tomorrow. That's so quick though, isn't it? How quickly did they make that video? No, I meant to take only a single thing off. When was my last video? 5 days ago. That's a week! That's a week! Peak stream. Yeah, I think it's gonna be out tomorrow simply because I'm really close to finishing it. I'm around halfway done at this point. And so yeah, I'm gonna go work in the video. It was fun. I'm also gonna research this off stream, and tomorrow I also have one more thing to do, unfortunately, though. So I won't be able to spend all of my time working in the video, but still, it should be finished tomorrow. Anyway, for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.